angular displacement, angular speed, and angular acceleration are all vectors. So you might ask yourself then, what direction do they point if they are vectors? Because if you think about a rotating object, each part of the object is going in a different direction. Here we have a wheel, and you know that this part of the wheel is going this way, this part of the wheel is going this way. So if you have all the parts of the wheel going in different directions, what direction do they point? So by convention, we use something called the right-hand rule in order to determine the direction of these vectors. So the way the right-hand rule works is that you use your right hand, it won't work with your left, you'll get the opposite answer, and you curl your fingers in the direction of motion. So imagine grabbing the axle of the wheel and curling your fingers around that axle in the same direction that the wheel is rotating. Then the thumb will point along the axle in the direction of the vector. And this vector will be perpendicular to the plane of spin. So if you wrap your hand around the axle in the direction of the rotation, your thumb will point in the direction of the angular displacement. This same direction is the direction of the angular velocity. And the direction of the angular acceleration will depend upon whether the object is rotating faster and faster or whether the rotation is slowing. If the rotation is speeding up, the angular acceleration vector points in the same direction as the displacement and the angular velocity. If the object is slowing down in its rotation, then the angular acceleration vector points in the opposite direction to the angular velocity. So here is another question for you. If a car's wheels are replaced with wheels of a greater diameter, will the reading of the speedometer be accurate?